Hello guys and welcome back. My apologies, my video got cut off because I ran out of time. Anyway, we'll pick up right where we left off, looking at the apply problem. This is on page 301 of your textbook. The table shows the supplies a school supply store has left at the end of the week. The store manager wants to put pencils and notepads together in bags to sell as a combo pack, and he wants to make the greatest number of bags possible. If all of the pencils and notepads are distributed evenly among all of the bags and the store charges $4 per bag, how much money will the store bring in if they sell all of the bags? So let's take a look at this information. Well, the first thing that we have to figure out, let's go back to the problem. They want to know how much money will the store sell if they sell all of the bags. The first question is, how many bags do they sell? That's what we need to find out before we can find out how much they will make. So let's take a look at the information. We are told that he wants to put pencils and notepads together. So do we need to know about the pens and erasers? Nope. So I'm going to cross those out right here. So let's look at this. We have 48 pencils and 36 notepads. We want to make the greatest number of bags possible. In this case, now think about it. Are you looking for the GCF or the LCM? Obviously not the LCM, because your supplies are limited and you have to distribute what you have. So you're going to look at what is the greatest common factor to figure out how many bags can be made, because you can put a different number of quantities of pencils and notepads in each bag, but the total number of bags that are going to make is the same. So we're going to find out how many bags can be made by looking at the greatest common factor. So I'm going to use the tree to figure this out. So I'm going to, let's say, instead of doing it vertically, I could do it horizontally. So let's find out the factors of 48. So that's 2 times 24. And the 2 carries over. I can make this up as 2 times 12. Again, I can write 12 as 2 times 6. So that's 2, 2. And 6 can be written as 2 times 3. I'm going to make a similar tree for the notepads. This can be expressed as 2 times 18. That would give me 2 times, again, 8 can be expressed as a product of 2 and 9. So that would be 2 times 2. Again, 9 can be expressed as a product of 3 and 3. Right? So now that I have my prime factors, I'm going to look at what are the common factors, and I'm going to circle the common factors between the two. So I can say this 2 and this 2 is a common factor. This 2 and this 2 is a common factor. Now I cannot go any further on the 2's because there are no more factors of 2 for 36. So next I'm going to look at 3's. Let's say I have this 3 and this 3. Now I do not have any more factors of 3 available on my 48. So this is it, guys. My common factors are 2 times 2 times 3. So that's 4 times 3, 12. So that gives me the number of bags that they will be able to make. Now that I know the number of bags, and I'm going to say, you know what, I should have written this first. Number of bags equal to GCF of 36, 48, which is equal to 12. So now I can say amount made money made by store. Remember, that's what we needed to find out. That's 12 times $4, that's $48, right? Awesome. Now let's think about this. Suppose this manager wanted to distribute the erasers evenly. Distribute, again, now the erasers evenly to the combo packs in addition to the pencils and notepads. When adding the erasers, alter the number of combo packs that can be made. Let's take a quick look at this. This time we don't want pens. We're looking at pencils, erasers, and notepads. Now let's take a quick look at this. I'm going to say, remember this one we already used 12, so I'm gonna just write this as 3 times. Sorry, I take that back. Now 3 times, 4 times 12. 36 was 3 times 12. 60. I'm just gonna continue with the 12 because let's say, or rather, let me break this down. 2 times 30, that would be 2 times 15. That would be 3 times 5. Again, if you see, we still continue to have our common factor of 12. So again, the common factor, the greatest common factor between these 3 is the 12. So the number of combo packets that can be made is not going to change because of erasers in this case. Awesome. Well, work on this check problem on your own. Pause the video here, work on the check problem, and I'll show you the answer, and then we can discuss how to work on this in class. There you go. Your final answer for this one is 45. And I also want you to do this pause and reflect, create a graphic organizer that will help you study the concepts of GCF and LCM. Consider including multiple methods of finding each. And I'll see you in class tomorrow.